Looking at lesson 11.2, analyzing arithmetic sequences and series. An arithmetic sequence has a common difference between consecutive terms. So looking at this example on the slide, right here, we have 1, 4, 7, 10. That is an arithmetic sequence because it has a common difference here of 3, right? It's plus 3 to get from term to term. So anytime you add or subtract to get from term to term and it's a constant, then you have an arithmetic sequence. In an arithmetic sequence, the difference of consecutive terms is constant, and this constant difference is called the common difference. We denote it in our formulas with the letter D. So looking here, we have the formulas for arithmetic sequences and series. So this first formula here will give us any term in the sequence, right? A1 is our first term. N is our term number. And D is that common difference. It's pretty awful writing there, but you get the point. Right? Common difference. The second two formulas can be used to find the sum of terms. This is the most common of the two formulas. The top one, sometimes written n over 2 times a1 plus an. It'll get you the same place. Looking at our first example here, they want us to find the 20th term. So our n value here is 20. Our first term is 3, so our a1 is equal to 3. The one thing they do not tell us, but we can figure out, is that common difference. How do I get from term to term? And right here is a pretty telling, right? How do I get from 10 to 17? Well, it's plus 7, right? And I would want to double check that that works for, right, 3 to 10. 3 plus 7 is 10. 10 plus 7 is 17. 17 plus 7 is 24. So here I have a common difference of 7. At that point, then I can use the formulas on the formula sheet that you will have access to on test day. That formula being any term is equal to our first term plus n minus 1 times the common difference. So just a quick note with this n minus 1, we don't use the full n value because our first term is already accounted for. So we have to subtract 1 from our n value so that we don't get ahead of ourselves in the pattern. So in this case, the 20th term is equal to 3 for my a1 plus 20 minus 1. And I understand you would probably mental math that 20 minus 1 step times the common difference of 7. Okay, 7. And then I would just calculator that, right? 3 plus n minus 1 is 19 times the common difference of 7. So the 20th term here would be 136. In example 2, we are writing the rule. It says write the equation for the nth term. So as I'm trying to figure things out for example A and B, honestly, our n value is going to stay as just n because they're not telling us a specific term. So here I have an a1 of -8. And then I have to find my common difference. -8 to -6 to -4. Everything is increasing by 2, so plus 2. So I would stay with an equals a1 plus n minus 1 times my common difference of 2. For part B, they tell us everything so neatly here, right? So I can just start with an equals 11 plus n minus 1 times the common difference of negative 11. Okay? Now, in our formula sheet, they don't put the parentheses around that common difference, but we need to denote that multiplication in some way. Arithmetic means, finding the arithmetic means in the sequence. So we have a sequence, and we know it is arithmetic, but what we do not know is the common difference, right? I don't know how to get from term to term. I do know, however, that I can go from 21 to 45. So I need to figure out this big jump here so that I can divide it out into these smaller jumps, right? So I'm going to go last term minus first term. Okay, so 45 minus 21 is 24, right? So that is the big jump, plus 24. However, there are 4 smaller jumps built into that one big jump, right? So I need to divide that big jump of 24 by 4. Okay, don't count the lines, count how many jumps, right? 21 to the first blank, to the second blank, to the third blank, to the 45, 4 jumps. So I have a common difference then of 6, because 24 divided by 4 is 6, and I know then that each of these small jumps is plus 6. 27, 33, 39, and then 45. Right? So arithmetic means we take the big jump, divide it into however many smaller jumps. For question 4, they want us to find the sum of these terms. So my sum formula is equal to n over 2 times a1 plus an, right? First term plus last term. So I can fill that part in. I know my first term is 8. I know my last term is 80. However, I don't know my n value. So I'm going to have to work to figure that out. So what I can do is find that common difference, right? How do I get from term to term before it's a series and it's just a sequence of numbers, right? I have a common difference of 4. So I know that to find a specific term, an equals a1 plus n minus 1 times the common difference. So to find the n value for 80, 80 is equal to first term of 8 plus n minus 1 times the common difference that I figured out was 4. Okay, so I'm going to use algebra to solve this up, right? I'm going to subtract 8 from both sides. I get 72 equals n minus 1 times 4. So at this point, we can divide out the 4, right? Divide out the 4. Leaves me with n minus 1 on the right side. 72 divided by 4 would be 18. Right? And then I would add the 1 to both sides. So I get n equals 19. That will set me up then to finish out the series formula. So now I can plug this 19 in here and here, right? So the sum of the first 19 terms is equal to 19 over 2, my n value over 2, times first term plus last term. So 19 over 2 is times 88 is equal to that sum. And then I'm just going to plug that into the calculator, right? 19 over 2 times 88 is equal to 836. Right? So the sum of the first 19 terms is 836. It required me in this case to do a little bit of preliminary work because I didn't know the n value that went with the 80, right? I didn't know this number there. So I had to use the other formula, the sequence formula, to find a term, and I plugged in what I did know. I knew that it was the term was 80. I knew first term, and I found the common difference of 4, right? So that I could find this n value to use in the series formula. So that is it for lesson 11.2.